Hello again, it's Miss Murphy, and today we're going to practice equivalent equations, and we're going to complete the solving strategies assignment in order to understand equivalent equations. So we have four different equations here. Some of them might be equivalent. I'm going to open the graphing calculator, and I'm going to type in each equation to analyze. Okay, you should always be practicing with your graphing calculator. There we go. We have two equations. As you can see, the red equation has an answer of -4. The blue equation has an answer of -4. So I'm going to put the answer in here. X equals -4 for the first one. X equals -4 for the second one. Okay, our third equation. That one popped up over here, the green one. X equals 4.5. Excuse me. And then our last equation, we'll type that one in, equals 10. Okay, that one is a purplish color, and again, that's x equals -4. So three of these equations have the same answer and the same graph. So that means they are equivalent. And the other one had a different solution. The graph was in a different location. So this is the one that is not equivalent. Okay, so how do we know if things are equivalent or not? Well, we could graph them or we could analyze the algebra within the equation. Okay, we're going to do both to try to understand. So I'm going to graph the first two groups. So I'm seeing that this solution here is 8. And the other one in the group also has a solution of 8. So these are equivalent. And how do we know that? Well, if we used our properties to combine like terms, we would minus 2x on both sides. Well, 5x minus 2x gives you 3x. So this second equation is simply just a more simplified version of the first one, and they are equivalent. All right, let's look at the second group. How do we know that these are equivalent? Well, let's take a look at the graph. So our first one has an answer over here, -6.5. And if we keep going, the second one, -6.5. So again, we have equivalent equations. They have the same answer, same graph. So what do you notice about the equations that make them the same? Well, I'm noticing that -4 is a multiple of 12. If I multiply it by 3, -3, I would get 12. And then this expression over here, 2x plus 9, is also being multiplied by -3. So both sides of this equation are being multiplied by -3 to get the top one. It's just simply a multiple of one equation to get the other. So they are equivalent. Okay, this last one, let's go ahead and look at the graph. And I'm not seeing, there it is. So the solution there is 34. And then we have, now this one has a solution of 26. So these are not equivalent. How do we know that? Well, I'm seeing a multiple of 2 on the constant term. 9 times 2 is 18. I'm also seeing a multiple of 2 with the linear x term. So a half times 2 would give us 1x. So that's looking good. But then this other value is not multiplied by 2. So if you're going to be a multiple of an equation, each term should be multiplied by that same constant. And that's not happening here. So these are not equivalent. They had two different answers. Okay, so let's analyze some work here. It is easy to solve equations using the graphing calculator as I demonstrated on the first couple slides. However, our job is to understand the step-by-step algebra process to get the answer. So yes, you can graph it. We can see the answer is 5, but you will be assessed on your quizzes and tests on the steps. So um, let's see what's going on here. Maybe a few different strategies. So Sadia is dividing by the denominator. 15 divided by 3 gives us this 5. And then 12 also divided by 3 is giving 4. So that's her first line of work. And then from there, we have a negative 4. We use opposite operations. So we're going to add 4 on both sides. 6 plus 4 is 10. Negative 4 and positive 4, that cancels out to be 0, so that's gone. Okay, again, combine like term these x's. We need opposite operations. We're going to add 7x on both sides of the equation. Whatever you do on one side, you do on the other. So negative 5 plus 7 is 2x. And then the last step is to divide by 2. 10 divided by 2 is 5. Okay, Amir used a little bit different strategy. Instead of dividing these numbers by 2, or by 3, he multiplied both sides by 3. These 3's would cancel, and 3 times 6 is 18, and 3 times 7 is 21. And from there, um, Amir kind of followed the same strategies as Sadia, where you use opposite operations to solve. So let's see here. The first step is to add 15x on one side and add 15x on the other. Negative 21 plus 15 is negative 6. And then we're going to subtract 18. Two negatives make a number that's more negative. So negative 12 minus 18 is negative 30. And then divide by negative 6. Negative 30 divided by 6 is 5. So same answer, different strategies. All right, let's see here. Now here's two students' work, and it's the same problem as the last slide, but they both got the problem wrong. So let's look at their work and try to figure out where is the error. Again, that's our job in learning algebra, is to know the individual steps and to understand that process. So Caleb divided by 3, looks good there. And then from there, added 5x. Let's see here. Oh, I see. Okay. So that side is right. It's this side that's the problem. So these two things are not like terms. This is a 6, which we call a constant. There is not a letter x next to it. This is a 7 with an x. You cannot put these together, and Caleb did put them together. So that part is wrong. Do not combine numbers that are not like terms. Okay, where's the problem here? Roberto made a mistake too. Um, where is the mistake? Okay, so in order to move the 4, it's a subtract 4, so you would have to add 4 on both sides. 6 plus 4 is not 2. 6 plus 4 is 10, so that's Roberto's error. All right, lots of different equations to solve. If you are solving these equations and maybe working on homework, you can always do a split screen. It's my preferred method for solving. Open a new tab and drag it to the other side. And pull up your Desmos calculator. So how do we solve equation A? We are going to type in the problem. And notice how I'm using an X instead of A. The graphing calculator will not recognize your work unless you are using values of X instead of A. I'm forgetting an equal sign right there. There we go. That looks better. So the answer to the first equation, equation A, the answer is 2. All right. Now, if this was a multiple choice assessment, you would just type in 2. That would be your answer. If you had to solve this step by step, then you can show your work here. You can cut and copy and paste. And I'm going to give you an example of that. So using the distributive property, we would get 4x plus 3, and that equals 17 minus 3x. Again, I know I haven't made a mistake because my answer hasn't changed. So I distributed the 2. I still have the same answer, but I'm showing my work. That's the important part. So next step, we're going to combine like terms. I can add 3x on both sides. Okay, I can drag this box to be a little bigger. Opposite operations like negatives and positives of the same number are going to cancel out. And down here, we're going to combine the x terms together. That's going to give us 7x. We haven't done anything else with the other numbers. My answer is still 2, so I haven't messed up because the answer should not change. Next step, again, opposite operations. We're going to minus 3 on both sides. Positive 3's and negative 3's cancel out. And we get 17 take away 3. That's 14 on the other side. Looking good. And then we can show our work further by dividing by 7 on both sides. So 14 divided by 7 is 2. So you not only have the answer, but you have all the work. So if I were you and you go to the snipping tool, click New, and you capture all your work like this, and you save that. To your downloads, and then you can upload this picture anywhere you like so that you are showing your work. That's my tip. Some of the quiz questions and the test questions are going to require you to show your work by uploading a file, and this is the best way I can show you to be able to do that. Okay, so I'm not going to go through all these examples. I'll come back in another call and I'll do some more examples for you. But for right now, that's as much time as we have. Thank you.